Hi, I'm Alex, the CEO and co-founder of Respeecher. At Respeecher, we apply AI to let one voice sound exactly like another voice. We are a deep tech startup, 15-people team, went through Techstars, Comcast, and BCU accelerator. Our technology was used in one big Hollywood blockbuster previous year, and the main target market for our technology is content creation, where we solve pains in voiceover and given a new creation tool. There is a very short demo of what we built.
Hey guys, here's a short demo of our voice conversion technology. We'll be converting my voice to the voice of Barack Obama.
What we've said consistently is that there has to be a political settlement to bring about genuine peace in the region.
The system captures the idiosyncrasies of how I say something each time I say it. I can say the same thing many times. The same thing many times. The same thing many times. And each time the recording will be correspondingly different. This makes voice conversion suitable for applications where the result should have the personality and range of emotion of a real person.
I'll talk today about how audio synthesis technologies can change the life of media creators, and I'll start with a small history overview. There were a few disruptive times in the industry. So the pioneers in applying something besides just recordings for content were people working in BBC Radiophonics workshop. It was created in 1958, and the goal was to produce incidental sounds and new music for radio and later television. On the image you see Daphne Oram. She was a senior studio manager, and she's surrounded with tools they were using in the BBC Radiophonic workshop. They had very limited techniques to use, and actually skizzers and tape glue were their main instruments. You could have heard some BBC Radiophonic workshop sounds in Doctor Who theme music. A few years later, the era of synthesizers began. Synthesizers are electronic instruments that generate audio signals, and it actually takes nothing on input except electricity. And here you see Robert Moog. Many of his inventions became standards of synthesizers, and it gave a push for many modern tools that are now used in sound production and post-production. And then the era of AI began presently. AI allows to apply a variety of machine learning techniques to generate sound and change sound in the different ways that many of comprehensive sound post-production tools allow. Most of AI solutions for audio generation use deep neural networks, deep learning, what we call it. It's a part of broader family of machine learning, and deep learning actually applies artificial neural networks to do such complicated stuff as audio or video generation. And people actually already use AI in content creation. And there are a number of ways how do they do that. So AI can already generate texts. It can take a theme on input and create something that actually makes some sense. It's not very sophisticated yet. It's not that easy to understand what AI actually meant in that particular text, but that's fun, and that's being developed with a very high pace. So we should expect AI generated texts in the content very soon. AI can generate music, and that's actually huge, because content creators that do not operate such big budgets as like Hollywood movies can already use artificial royalty-free music for their content. AI lets content creators swap faces and do very high fidelity lip syncing. I highly recommend the talk of Victor Ripabelli, founder of Synthesia, and they created a very cool product in AI video generation field. And finally, AI can synthesize voice. It can synthesize voice from text input, that this technology is called text-to-speech, and it can change voice using another voice on input, and that's what we do at Respeecher. It's called speech-to-speech. I am more focused on speech synthesis technologies in this talk, and to give a sense on how it can already help, we should mention that speech synthesis solves many pains in voiceover. It can scale voices, give creative flexibility to content creators. We actually can remove these borders we always had when there is one person, one voice, and they are tight and short. So, there are two main approaches to synthesize voice. The difference is in input, and the first one I want to talk about is text-to-speech. Text-to-speech generates voice from text, and there are a lot of text-to-speech startups. Some of them are also doing what is called personalized text-to-speech, when you can train the system on a particular voice data set and then generate the voice you need from the text input. Just type new lines and get the sound. Let's have a listen to a couple of examples we think are cool in text-to-speech. One of them is from Well-Said Labs. Another one is from Sonatic startup.
The aircraft situation display provides information about airplanes flying over the United States at any moment. Each dot on the screen represents an airplane in flight. Can you guess how many airplanes are shown on this map? If you guessed 9 airplanes, you're right. For every one of those airplanes, the ASD knows its identification number, location, speed, direction, and altitude.
And the second one?
Oh no. We've been walking all night. Can we just take a break?
Yeah, so what's cool about text-to-speech, it's very easy to use. There are no humans in the loop, just input text and let AI generate the voice track. But there are some significant limitations of the text-to-speech approach. The first one is very limited control over the emotional content. So you cannot actually make the stuff sound exactly as you want it to be said. Text-to-speech already gives some control, so you can make it sound excited or like generally calm, for instance. But what we know, content creators look for having more flexibility there to operate with the emotional content. And also, being tied to language model, text-to-speech struggles with unusual words, foreign languages, or nuances like humming or giggling. It also doesn't work properly in the languages that do not have reliable language model. Regarding the data, to make good text-to-speech model, it's often required to have a lot of training materials, like hours of good recordings, to get to the good level of the sound on output. But things change with a very high pace in the area, so it could be changed soon. Then, speech-to-speech, our approach. On the other hand, it uses voice on input and changes the voice of one person to the voice of another desired person. And the main limitations comparing text-to-speech, our current best system requires training on a pair of voices, and we do keep voice actors in the loop. They have to deliver these new lines. But what's different is sound quality. Speech-to-speech doesn't sound robotic, and the reason for that, it transfers the emotions from real human. It gives a creative control. So when you do speech generation using speech-to-speech technology, it allows to content creator to actually say to voice talent to produce lines with the exact emotion as, say, director of the movie wants it to be produced, and the system would preserve the acting while just changing the voice when we do the processing. And also, speech-to-speech approach operates solely in acoustic domain, so it's language agnostic. Any words, abbreviations, unusual names, all other sounds our vocal apparatus produces could be changed to the desired one. This is a very short overview how our speech-to-speech system works. There are 5 steps, and the first one is to get permission from voice talent. We always require that. We always require our clients to get consent and permission of the target voice before even starting the project. And then we need to collect a target voice data. We currently ask for 1 hour of high quality target recording, and that could be something that already exists, some existing recordings, or it could be something new, recorded specifically for the project. The target recording should be just clean, better studio quality, no other voices, no reverb, no background noises. I mean, the better data we feed in the system, the better output we have. Then we need to collect a source voice data. The source voice actor goes to studio and records the lines from the target voice recording. So actually, source voice has to repeat these lines and also repeat the intonation. To simplify that process, we usually split the target recordings to small chunks, like 3-5 seconds chunks. Then source actor repeats chunk by chunk, trying to keep the same emotions. Then we take this data, and that's called parallel data set for us. We proof-listen to that to make sure that everything recorded properly, because deep learning models, they usually rely on the high-quality data. It should be consistent in terms of the structure of the data. So we proof-listen the stuff to make sure that lines were saved properly with the same intonation, and there were no mistakes, and we just can throw away bad lines, or if there is no enough material, ask client to redo some source recordings. And then we do our magic. So that means we feed the parallel data set in our system, and the system is actually pre-trained to understand difference between 2 particular voices, and it analyzes this data set, presumes that there is no difference in content at all, and in a day or 2 it can actually say this difference, and we can feed their new lines and do what we call inference, create new recordings, do voice conversion. That's a simple infographic how it works. So there is Daniel, who is a target voice. There is Grant, the guy you've seen in our first demo. Grant went to studio, did the recordings after Daniel, then recorded some new stuff, and this new stuff was converted to Daniel's voice. One more short demo.
Hi, I'm Grant, a co-founder of Respeecher. In a minute, you'll see a video of Daniel Cohn, the head of Lift Labs, and then you'll see a video where I speak in Daniel's voice.
You are listening to the Ideas Elevated podcast of Comcast NBC Universal Lift Labs. The system captures the idiosyncrasies of how I say something each time I say it. I can say the same thing many times, the same thing many times, the same thing many times. And each time, the recording will be correspondingly different.
Yeah, let's move to the applications we validated for content creators. So, filmmakers, animation, TV producers, they usually waste a lot of time by bringing a high-demand actor back to studio to do recordings after the principal shooting. For example, according to Tom Hanks, it can take him up to 2 hours just to get one line right on this ADR process. And for each movie he participates in, it's 2 days booked for recording session. Quite boring and annoying work in the studio. Documentary creators often need to bring back the voice of an actor who has passed away. And just imagine a movie like Bohemian Rhapsody, where the actor actually speaks in the real Freddie's voice. So it would sound much more exciting to me. Another cool use case is the aging voice. A good example is the Gemini Man movie. So there was Will Smith. He was playing two roles: the young guy and himself in his current age. They applied sophisticated CGI to make his look younger, but they should also have applied Respeecher to get his young voice. It's not that easy to use kids' voices, for example, and especially keep these kids' voices consistent in the derivative content. Kids grow, voice can change, and in the next animation series you would like to actually use the same voice you used in the previous series. Dubbing and localization is very big market, and in dubbing and localization use cases are actually similar to film, TV and animation, but what particular about dubbing and localization, that technology could possibly allow original voices sound in other languages. For example, Tom Hanks would speak German in Tom Hanks' voice. We have currently some limitation with our system which called accent, and when we make like cross-language conversions from native American speaker to German language, German listeners would hear a very thick American accent on output, but we are on our way to get rid of accents. Video game developers, they're actually huge. They need to voice over dozens of hours of audio, and they desire to use famous, recognizable voices in their games. But someone like Morgan Freeman wouldn't spend weeks in studio to do that work. And what's even more challenging for video game creators, when you do a video game, you need to implement changes all the time. This process is even crazier than in film or animation creation. And for doing that, you need to get Morgan Freeman back and back to studio multiple times. That's a huge logistical challenge, at least. The tech actually could allow another available voice actor do this job, or even few available voice actors do this job. Advertisers, they're now able to create many like granular pieces of content. I mean, imagine like a specific script for each local radio station or for each like small segment of the audience. Big brands usually have a deal with someone who is like a face of brand, like famous soccer player. And what they actually can do using synthetic media is to scale these personas for the content, for advertisement content they create. And they can voice over like tons of advertisement pieces and actually also use video synthesis to make the look right. Audiobook and podcast producers, now they can actually get author to narrate their own book, even though they are not classically trained as voice actors. Getting famous voices recording the piece of content and actually being able to pick the voice you want to use for listening to audiobook. I want to show one cool use case for the historical content we did previous year. The project was managed by MIT Center of Advanced Spirituality, and the idea was to create a piece of alternative history. So we actually made President Nixon, say the speech that was written for him in case if Apollo 11 mission goes wrong and the moon landing becomes a catastrophe. The speech is very powerful, but it stayed in archives for years. And this piece was presented on Amsterdam Film Festival previous year. And what's also interesting about it, we partnered with Kenny AI, a company from Israel that made a video part. So they applied their video synthesis techniques to make the visual representation of Richard Nixon saying this script. Let's take a listen to the trailer.
Good evening, my fellow Americans. Fate has ordained that the men who went to the moon to explore in peace will stay on the moon to rest in peace. For every human being who looks up at the moon in the nights to come will know that there is some corner of another world that is forever mankind. Good night.
This case is about like history and bringing history back to life, giving history like a new breath of making it more like close to you when you can actually listen to the stuff that was used, the voice of the particular historical figure, or you can see them acting in the piece of content. Sounds like a very powerful use cases of synthetic media technologies. And one more topic that's very important to talk about, and that's always on people's mind when they hear about deepfake related technologies, scared about their capabilities. And there are few important thoughts I have here. So the first one, we need to understand that technological progress is inevitable, and the tech will be there anyway. The second one, video and voice synthesis techs could be dangerous. So while we at Respeech are using it to revolutionize movies, video games, and other creative projects, it can also fool people into thinking that someone said something they actually didn't. Some ethical questions about synthetic speech are quite easy, some are hard, and our approach, we just don't rely on our gut to tell us what is right and what's wrong, and we build a set of principles that guides us through decision making. The one important principle is Respeecher doesn't allow any deceptive use of our technology. We do not use voices without permission when it could impact the privacy of the subject or their ability to make living. In practice, that means we will never use the voice of a private person or an actor without permission, but we do allow some non-deceptive use of the voices of historical figures and politicians such as Richard Nixon or Barack Obama. It's all well and good to have strong principles, but the next question is how we can ensure that these principles are not violated. And for that, we have following approach. We do not provide any public API for creating or using voices, unlike many text-to-speech companies. We work directly with clients we trust, with studios. We always require the written consent from voice owners. We only work in projects that meet our strict standards. And we are right now in the process of developing the watermarking technology, audio watermarking technology that would allow easily tell Respeecher generated content from other content. Watermarking would mean just putting some audio that is not hearable for humans, like on very high frequencies or on very low frequencies, but would create some particular picture, like a watermark on image, that could simply say that this piece of content was synthesized by Respeecher. Of course, we are not the only ones working on synthetic speech technology. And as leaders in this space, we feel a strong responsibility to mitigate the impact of unethical use of this technology by whoever produces it. We are just getting started in this area, but the goals are simple. The first one is to educate the public about capabilities of synthetic speech technologies. The second, we are going to develop automatic detection algorithms that can detect synthetic speech even if it has not been watermarked by us. And we are going to work with gatekeepers of content such as Facebook or YouTube to limit the harm of voice cloning by bad actors through prominent labeling of all synthetic content and banning of particularly unethical content. So that's actually what I wanted to cover today in terms of topic, and would love to jump in to the Q&A session. Thank you so much.
Yep, we are live, hopefully. So thank you a lot. This is very interesting, and apparently by the end of your speech, you just answered the questions we had in our Q&A chat. So,
yeah, actually, this question about natural intonations, the text-to-speech is great. I mean, when you think about naturalness of the speech, you think where the model, AI model, should get this information, and when you have only text on input, it's nothing about the intonation itself there. So the problem that model should just imagine these kinds of intonations and just give it to you in the output. And these text-to-speech companies, they already have some kind of cool features of giving like editors for content creators where you can choose how it should sound. And these editors would be more and more sophisticated, but it's hard to imagine for me such kind of editor that would be as sophisticated as taking the information from like real speaker regarding the emotional natural intonations.
So are we basically talking about people training AI to sound naturally?
Yeah, I mean that could happen, but still, when you just have only text on input, the model doesn't know how to say it in the exact way to make it natural for this particular situation, and that's a complicated problem.
And it does look differently from other directions of artificial intelligence. I mean, like, for example, if you go into the self-driving technology, and what they do is that they basically just let their cars go through the streets around the cities and just collect information around them and learn out from it, right? So then they are getting these loads of big data about surroundings, and then they are building their own maps. They are trying to understand where are the obstacles on their way, etc. So the question is if your kind of technology, because I understand that artificial intelligence is a huge thing and it has many, many, many directions. And so I'm just asking if your particular direction can do like that. Like, can you just really load your machine, your software with loads of this kind of data and train them? Or is it just really case by case thing and it's really hard to catch the emotions and intonation of humans to transfer them into the machine?
Yeah, I mean, we should split that between like text-to-speech approach and speech-to-speech approach. So for text-to-speech, I mean, there are like two ways. First way, you will get like very cool, big, sophisticated editor to pick like different stuff to make it sound as you want. And for being as flexible as we are when speaking, it's quite sophisticated stuff. Another way, models could generate like tons of versions of the same line, and you would just pick the best one. So it would be like 1,000 versions of intonations, and you would pick the best one. In our case, I mean, we always take the intonation from the real speaker, from the real human, and that's speech-to-speech approach. But we also do apply some kind of techniques where there is like some patterns of intonation, some patterns of speech that are not presented in the data set, but they need to be in the output. So for example, for one of our contracts, we had to make our target voice whisper, but our model at that time wasn't able to do whispering. And we had no whispering in the target data set. So what we actually did, we took like many people in the studio and we made them record whispering data set. And then we applied these techniques called transfer learning, where model can just understand how human can whisper and apply that for this particular target voice and transfer this learning to the target voice. And then we ended up having our model being able to whisper.
Okay, that's very interesting. Do you hire?
Yeah, we actually closing the last open position today or on Monday.
Okay, because I'm sure that we will have many more candidates for your company soon while sharing how great tech are you actually building. Okay, another question here. I think it was also answered already because you were talking actually about public API. Is it possible to add this to mobile apps and use it as a filter, for example, during calls or on social media?
Yeah, I mean, that's possible. That also very dependent on the on our progress on the technology. So right now, our best model requires quite complex training. So for end user, you would need like spend 1 to 2 days in studio to actually prepare this particular data set for a pair of voices. But we have the R&D stream that's called non-parallel voice conversion. And the goal of this stream is to get rid of this parallel data set so anyone can operate with any other voice. That would be like many to one or even many to many. But yeah, that first should not contradict our ethics, and we are quite stick to our ethics. And second one, for the use cases, B2C use cases, like celebrity voice changer and that kind of fun stuff, it's no go for us because of ethics. But for such use cases where we can change our accents on the fly, or we can a bit change our voice on the fly, that's actually something we keep in mind, and we are going to have our real-time model first release by the end of summer. The quality would be a bit worse than in the main model, but for phone calls, for Zoom calls, even for Pine tool calls, it might work.
Wow, amazing! Because I also know that there is Armenian startup that is actually based in the US. Maybe you know about them, Crisp AI.
Yeah, sure.
AI. Sure, of course you know. They do what? They cancel any kind of noise at the background during the calls. So I think they could also use this time, this crisis, as a big dump for their project, because everybody is now using any type of conference calls software, and of course many people are sitting home with their kids or dogs or cats, and they really need this noise canceling on the background. So and it was actually a question for me, like why these kind of projects were not born earlier. I mean, like Crispy AI was launched kind of a year ago, maybe more, I might be mistaken, but like to my memory, it's just a year or something. So the question was like, at which actually level of all this technology development we are now, and where we can move further? Like, how do you think? How do you see this?
Yeah, I mean, when we talk about like the level of technology, the state of the art in the voice field, we should understand one important thing. When we look at images, our mind can just add something there. So we can just look at image that is not perfect, but we can make ourselves think that it's actually perfect, because we have this very strong imagination. But when we talk about sound, we as species, as humans, we are very picky about sound. And the reason for that we used our hearing, our ears, to protect ourselves for ages. And that goes nowhere. So when there is something wrong with sound, we always hear that. And that's a big problem for technologies that operate in sound, because it's very hard to make it sound perfect, and you always need to make it sound perfect, because if it's not perfect, it would be hurt actually. So I would say that we are like a couple years behind some technology that can generate video, that can generate image, and the main reason is because we are applying some of techniques, some best techniques from image and video generation in sound generation, but many of them do not work because of the reason I just explained. It just should sound perfect.
Wow, so that's really hard. Okay, we have another question in the Q&A chat from Toka. How easy is it to synthesize voice based on another person's voice for a noob? Are there tools, libraries available that would simplify this task? Or does it still require an advanced, experienced developer to achieve it?
What's noob?
What's noob? Can you elaborate on that, Toka, in the chat? What exactly do you mean?
Yeah, I mean, in terms of how hard it's to synthesize voice, for like doing the best work we can do with voice, it could be a project of a couple of weeks at least to find the target data, to prepare the data set, to make sure the data set is correct, to listen to the data set, to train the models. And we still keep experienced developers in the loop, because our state of technology still requires us to make sure that model works perfectly for this particular data set, maybe tweak some parameters to make sure that it works perfectly. So I mean, that's the reason why we still go on the project to project approach. But yeah, I really do hope that we can automate this process very significantly, like by the end of the year.
Yeah, so actually Noob was the newbie of a beginner. Thank you for explanation. Yes, actually you have answered the question in the end, that it will really require some more sophisticated professionals to make it more accessible to newbies soon.
Yeah, but I mean, there are many GitHub models. You can just take a look at some voice cloning, voice conversion, speech to speech, speech to text models. You can find something from GitHub, but it would be hard to make it sound on the very high level of the quality.
Okay, any other questions as we are coming to the end of the session? And I have a lot of questions, so I can continue for ages. Okay, cool. Anyways, if there is no questions, you can still, guys, leave your questions in the event chat, in the general one. In the end of the event today, we will come to the chat and we'll be discussing the topics we have discussed today during the talks. So Alex, if you will be available, please also join us in the evening. You can see the in agenda as live discussion. I think the guys will come up with more questions, actually. At least I will. At the moment, thank you a lot for joining us. Hope you will be really successful with all your collaborations with the companies you've been talking about, because I think it's a really revolution and it will move forward a lot of things in terms of business, technology, and entertainment in general. So thank you a lot.
Yeah, thank you so much.
Okay, and meanwhile, I will tell you that we will now move to the break, but during this break, we have something special prepared for you. We will have a cocktail masterclass streaming online, and after that, we will have a space industry panel where we will have our friends, our guests from space industry talking about opportunities for career growth and business in the space industry. For now, see you at the cocktail session. Ciao.